density plots. To talk about a density plot, let's use the following data here. Let's say we have a data set that contains the numbers 4, 3, 7, 5, 5, 3, 4, 4, 4, and 2. And we want to create a density plot of these data. So we start with a number line that heads off in both directions here. Ours goes from 2 to 7. So here we would have 2, 3, 4, 5, 6, and 7. And what we want to do is stack up our data where they belong on that number line. So we have 1, 4, a 3, a 7, 2 5s, another 3, 3 4s, and a 2. Okay, so we put the data where they belong on the number line. What we want to do now then is suggest that entire data set with a curve that runs along the top of these data. Okay, and then we get rid of the numbers aren't there. We just have this line. Okay, that is a density plot. We're just showing the outline of the data and where it sits on the number line. This example is very simple because we had just a few integer values, but the thing that works really great for, where the density plot really excels is when you have complex data that go out, where you don't have repeats and you're stacking them all up together in a jumble, and you kind of want to just see where they fit on the number line. But that's essentially how it works. We stack the data up where they belong, and then we draw a curve across the top of them that shows where the data are centered and how dispersed they are on a number line. Obviously, then these numbers have to be interval ratio, right? Because they're sitting on a number line. We use density plots a lot because they're such a clear depiction of what a large complex data set looks like.
Well, after all the unnecessary complications I added into making a line graph, let's work on an easy one. Let's make a density plot in R. Let's start with the data set trees that we've looked at before. Just as a reminder, we'll look at the dimensions of this data frame. We'll look at the names of the variables, and we'll take a look at the first few values. So we'll send all that back over here to R. So I have 31 observations, so I have 31 trees in these data sets, in this data set, on 3 variables, which are girth, which is measured in inches, height, which is measured in feet, and volume, which is measured in cubic feet. And it looks like we have girth goes out to tenths of an inch, height goes to full feet, and volume goes to tenths of a cubic foot. We want to create a density plot of the height variable. Okay? So a box plot, if you remember when we were talking about box plots, draw a picture of the sample of our actual 31 trees. A density plot tries to predict what the whole population looks like. If I have a forest of 300 trees and I've sampled 31 of them, what would the density plot of the entire forest look like? So a density plot is kind of a projection or a prediction of what we think the forest would look like. There are 2 parts to it. We have to create the density plot, and in this case we're going to do trees $height, meaning of course that I have a variable called height that is inside the data set trees, and I'm just interested in looking at height. This calculates the density based on some probability density functions that are happening here in the back. It creates a function that predicts what the height will be for the whole population. We're not interested in that function specifically. We just want to take a look at what it looks like. We just want to see it. So if I dump that into the plot command, it's going to draw a line graph of the density plot of tree height. And so we can see that our most common tree height here is around 78 or so feet, but it ranges all the way down to about 60 and to about 90. We have the main bulk of our trees fit in right here, but we have some smaller subpopulation that have heights closer to 65. Okay, so it has drawn this curve that is an estimate of what the entire forest population looks like based on our sample. And that is the easy way of creating a density plot.